Hello, math students. We are still working in Module 1 called Ratios and Proportional Relationships. This is Lesson 5, and it is called Identifying Proportional and Non-Proportional Relationships in Graphs. So we're changing up our topic a tiny bit, and for the last couple of lessons, we've been talking about proportional relationships with tables. And today, during this lesson, we are going to talk about proportional relationships in graphs. So that's the biggest change. It says, our goal, today we are going to learn how to determine whether two quantities are proportional on a graph. The question that I want you to be thinking about in the lesson is, how are proportional quantities shown on a graph? So how do we do that? We're going to determine if they're showing a proportional relationship. How do we do that on a graph? How do we put them there? So things to learn. The first thing that you need to be very, very comfortable with working with graphs is the graph itself. You have to understand it. You have to know its parts. You have to know what the jobs are. And so we might need to do a quick reminder of that. But things to learn. A coordinate plane is another way to model a proportional relationship. This right here is a coordinate plane. A coordinate plane is a fancy name for a graph, okay? And the task that we're going to be talking about is Isaiah sold candy bars to help raise money for student council. For every 2 candy bars he sold, he received $3. Okay, so Isaiah is selling candy bars for student council, and he needs to make money, and he has candy bars to sell. And so our job is to figure out if he sells every 2 candy bars, he gets $3. We need to decide, or we need to determine if the values on here are proportional, first of all, and if the answer is yes, they are, then we get to go ahead and remember how to graph them. So the first thing that you need to do before you even start graphing is you have to decide how to graph them. And so the way that we do that, and this is why I mentioned it earlier in the early lessons, is this is known as the input side of our table. This is the output side of our table. And we also remember that this is most likely all of the time going to be the x value, and this is most likely all of the time going to be the y value. And so what we need to remember is you learned, hopefully in 6th grade, if not, then I will teach you right now, but you learned about ordered pairs. And ordered pairs tell us how to graph. So when you're building an ordered pair, you need to remember that you have to use parentheses. The x value always comes first, and then the y value. They're separated by a comma, and then you have to put the parentheses back around them. If you don't have the parentheses, then kids could get confused because they would just look at it and they'd think it was listing numbers. But we're not listing numbers, we're actually organizing the values. So for this first one, if we look at this first input value, which happened to be 2, I know that's the x, so do you see where the x is? So I'm going to write parentheses, the x value first, and the amount that came out of the x value was 3. So I put it right next to it and close the parentheses. So the first ordered pair that we have is 2, 3. The second ordered pair that we have is 4, 6. The third ordered pair that we have is 6, 9. The fourth ordered pair that we have is 8, 12. And then the last ordered pair that we have is a 0, 0. All right, so now we have all of the ordered pairs from the table, but we are trying to figure out if it's proportional or not proportional based on the graph. So we have to use this graph to help us. So hopefully in your 6th grade learning time, you also learned that this is the x-axis. Go ahead and label that. Sorry, you can't see it. And this right here is the y-axis. Now, the reason that I'm telling you those is because the x-axis numbers are right here. The y-axis numbers go up and down. So this, of course, is 0. And then I'm just going to start numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So those are the numbers on the x-axis. Now I'm going to do the y-axis. So the 0 is already there. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, so now we have both of our axes labeled with the numbers, but we're missing one thing. We now have to remember to put what it's called. So go back over to our table, look at the x side. What is the x side called? The x side is called candy bars. So we need to write candy bars under here so that our brain knows where the candy bar side is. Then the other side is money, so we have to write that right here. So again, our brain remembers that this is the money. So the candy bars go along the bottom and the money goes up and down. So this is how you're going to plot it. The first ordered pair that we have says 2 candy bars earned $3. So that means I go over here and I go 1, 2, and it earned $3. So I don't put a dot at the 1, at the 2, but at the 3, I put a dot because that shows us 2, 3 on our graph. All right, the next one said when he sold 4 candy bars, so 1, 2, 3, 4, it earned him $6. So 1, 2, 3, 4, 5, 6, and then we travel up to the 6 until we crash, and where we crash is where we put the dot. Okay, the next one says 6 to the right, 1, 2, 3, 4, 5, 6, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's where we would crash. And then the next one says 8 to 12, so I'm going 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way at the top. Phew, thank goodness that we didn't have to do another one because we'd have to draw in our own lines. Then the last one says if he sold 0 candy bars, he earned $0. Well, that makes 100% sense because if you don't sell anything, you're not going to earn anything. That's right. So 0 candy bars earns you 0 money. Go ahead and put that on there. All right. Now, here is the most important part, kiddos. You have to remember that when we're using graphs to determine if it's a proportional relationship, the way we check or the way we know that it is a proportional relationship or not is if it has a straight line. And looking at this, it looks pretty straight, but we're actually going to test it. And I'm going to use my ID. So hold on, let me grab my ID because it makes a perfect little ruler. So we are going to check to see if I was to draw a line to connect the dots, would it be straight? And if I could get my ID to behave, then you would see that I truly do have. Check it out, kiddos. What do you see? Hopefully everybody can see it. We have a straight line. So because we have a straight line, we can now say it is a proportional relationship. If you had a dot sitting over here and you had to go, ooh, then that would not be straight, okay? And so the fact that each point, when you connected it, it made a straight line, that tells you your graph is a proportional relationship, okay? So let's go over the characteristics of a proportional graph. It says points form a straight line. Ta-da! We did that. Awesome. The line goes through the origin. That means if you have 0, you're going to get 0. Ta-da! It does. And there is a constant. Well, let's check it because we never checked that. So now we're going to go back over here to our little table. Or, you know what? We can do it on our graph. This is what is really fun about using a graph is watch. I go 1, 2, 3, up 3, over 2. Oh, that's not bad. Let's try it again. Up 3, over 2. That's awesome. Up 3, over 2. Up 3, over 2. Okay? And that's pretty cool. It shows that each time I go up 3, I go over 2, up 3, over 2, up 3, over 2, up 3, over 2. Or we can do our check like I taught you before. which is not fun, but we could do it. 2 times what gives you 3? Well, I know this, and it's actually 1 1/2. Okay, so 2 times 1 1/2 gives us 3. 4 times 1 1/2 gives us 6. 6 times 1 1/2 gives us 9. 8 times 1 1/2 gives us 12. And 0 times 1 1/2 still gives us 0. So now, check it out. Do we have a constant? And the answer is yes, because each one was multiplied by the same amount. So the 3 things that you need to know in order for a graph to be proportional is the points have to make a straight line, the line goes through the origin, and there is a constant. This is one thing that I really, really love for kids to do, just because it's a lot easier. Make 3 boxes anywhere near your graph and check them off as you find them. So, straight line, and we get to put a check in that box because check out our graph, it's a straight line. Origin, did it go through the origin? You betcha. And constant. And what was the constant again? And I like to write it. The constant equals 1 1/2, so we get to check that one off. So that's how I always check my graphs to see if they're proportional. Okay? All right, let's look on the next page. So it says on this next page, check it out. The task this time is to wash a load of clothes, you need 3 tablespoons of laundry soap. Create a ratio table to see if it is proportional. Okay, well that doesn't sound so bad. Let's do it. So it says 3 tablespoons of laundry soap for 1 load of clothes. Okay, so 3 scoops or tablespoons of laundry soap for 1 load of clothes. So my question is, how much do you need if you need to do 2 loads? 1 load takes 3. 2 would take how much, everybody? You're right, do it 2 times. So if we're doing 1 load, we put the load in, how many do we have to put in? 3 scoops. If we did another load, put it in, and how many scoops? 3. But in total, how much have you used? That's right, 6. Okay, so the third load, you put another load in. How many scoops did you put in? 3. So we did that 3 times. So what do you get? 9. If you did a 4th load, remember, it takes 3 per load, so that would give you 12. And if you did 5 loads, 3 scoops each, 15. Nice job. So the thing that's pretty awesome about this is we can still check to see if we have a constant. But before we do that, let's go ahead and make our ordered pairs, because remember, you have to have ordered pairs to graph them. So remember that an ordered pair is always x first, y is second. So we have parentheses, look at the first x. Remember, this is always the x, this is always the y for now. So we have 3, 1. We have 6, 2. We have 9, 3. We have to put the parentheses around. We have 12, 4, and we have 15, 5. All right, so now we have our ordered pairs. Now we got to look at our graph. Nothing on it, so now we need to get to work. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same thing for this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we have those. What was this called again? This is the x-axis. What was this one called again? The y-axis. I'm saying it over and over to help you remember. The x value this time is laundry soap. Laundry soap. The y value this time is called load of clothes. Load of clothes. Okay. All right, now we can graph because we've got everything labeled, so we know what we're doing. All right, first one, 3 tablespoons of laundry soap for 1 load. So I go over 1, 2, 3, up 1, put a dot. All right, go over 6 this time, up 2. Go over 9 this time, go up 3. Go over 12 this time, go up 4. Oh my goodness, check it out, guys. We fell off the graph. So if we went 13, 14, 15, we'd be about here. And, hold on, 13, 14, 15, we would be about here. 13, 14, 15, and up to 4, which would be about there if we had the graph paper, and we could go on forever. But what happens? I do have to ask you. Okay, let's see if it has a straight line. Uh-oh. Here's the problem. Where do we start? Look at our table. Do we have it listed on here? If it's not listed, then you have to think logically. So ask yourself, if you have 0 laundry soap, can you wash clothes? No. So what is the answer to no? 0. So this one technically, logically, still works because 0 teaspoons or tablespoons of laundry soap makes it so you can wash 0 loads. So now we can put it in there, even though it wasn't on the table. And now that we have the origin, we have a place to start. And so I'm trying to see if I can get this pretty well connected. And it looks like it's going to go. So let's hook those together. And let's hook those together. Oop, my line curved. So don't worry about that because we're off the graph. But if I hadn't fallen off of my ID, it wouldn't have bent like that. So I'll just cover it up over here so you can't see it. Ta-da! Okay, so first thing we have to do to check and see if it's proportional, is there an origin? Cha-ching! Is there a constant? It looks like there is. Remember how I taught you to check on the graph. On the graph, you check to see if you travel the same way. So we went up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3. And so it looks like there's a constant to me, but if you're not quite sure, you can always check it over here too. How did we get from 3 to 1? Divide by 3. How did we get from 6 to 2? Divide by 3. How did we get from 9 to 3? Divide by 3. How did we get from 12 to 4? Divide by 3. How did we get from 15 to 5? Divide by 3. Kiddos, is it a proportional relationship? And the answer is yes. So in the constant, you get to put a check, and it's because we divided by 3. One quick review from our other lesson. Dividing by 3 is the same as multiplying by 1/3. Okay, so yes, there is a constant of 1/3. Is it a straight line? And we already proved that, so we get to put another check, and ta-da! We now have a proportional relationship on our graph, and you guys did it. Awesome job, kiddos. That's a lot of work, but you guys did a great job. Okay, very quickly, let's review our goal for the lesson. Today we are going to learn how to determine whether two quantities are proportional on a graph. We absolutely did that. The question that I wanted you to be thinking about is, how are proportional quantities shown on a graph? And the answer to that starts with an O, and it's 2 words. So it's 2 words, and I'm going to tell you one of the words starts with an O. So in your answer section of your notes in option 2, tell me what quantities are on a graph that starts with an O. If you're doing option 1, then just write it in the answer under that question. All right, kiddos, that's all I have for you today. I hope you had fun. Talk to you soon. Bye.